Hello everyone, welcome back to my YouTube channel. This is Shivram, and today in my video I'll be teaching you people to solve problems on instantaneous value equation of an alternating quantity. First things first, let us consider an alternating quantity A. So the instantaneous equation of this alternating quantity A will be given by A is equal to AM sine omega t, where omega t is in radians. Also, we know that omega is equal to 2 pi f. Therefore, I can write this equation as am sine 2 pi f t. Also, if I consider the angles in degrees, I can also write am sine theta. So I have three different forms of the equation. All the three are same. So we know that in an electrical circuit, we have voltage, and current. So if I write the instantaneous equation for voltage, it will be E is equal to Em sine omega t, or Em sine 2 pi f t, or Em sine theta. Right? All the three equations are one and the same. Only thing is, whenever I am using omega t, I am referring to the angle in radians, wherein when I use theta, I am referring to the angles in degrees. Similarly, for current, I can write small I is equal to Im sine omega t. Also, Im sine 2 pi f t. Also, Im sine theta. So you can use any form of the equation while solving the problems. Now, moving further, let us solve some problems on instantaneous value equations. So here is the basic problem or numerical which you can expect from the instantaneous equation. So the problem is like this. The equation of an alternating current is given as I is equal to 42.42 sine 628 t. Determine its maximum value, frequency, RMS value, average value, and form factor. Now, so the given equation is I is equal to 42.42 sine 628 t. Now, first one, maximum value. So because it is the current quantity, it is Im. We know that instantaneous equation of an alternating current is given by I is equal to Im sine omega t. Right? So if I compare this standard form of the instantaneous equation with the given equation. So let me name this as equation A and this as equation B. So equation B is the standard form wherein equation A is the given equation. Okay. So if I compare I they are same. So 42.42 in place of IM you have 42.42. So directly you can say that from comparing the equations IM is equal to 42.42 amps. So this is your first answer. Next one is frequency. Which is denoted by F. So we know that omega is equal to 2 pi F, which is given in radian per second. If I compare the standard equation Im sin omega t with the given equation 42.42 sin 628t, I can say that in place of omega I have 628. Therefore omega is equal to 628 radians per second. Therefore F is equal to omega divided by 2 is equal to 628 divided by 2 which gives you 100 Hertz. So the frequency of the given alternating quantity is 100 Hertz. Next, third one, I need to find the RMS value because it is the current quantity. RMS value is represented or denoted using IRMS. So we know that the relationship between IRMS and Imax is given by IRMS is equal to Imax divided by root 2. So we know Imax value, which is nothing but 42.42 amps. I'll substitute it here. 42.42 over root 2. If you calculate the value, you will get 30 amps. So 30 amps is the RMS value. Fourth one, I need to find the average value, which is denoted as I average. Again, I'll go with the relationship between average value and maximum value. So I average is equal to 2 by pi into Im. So I know what is Im value, 2 into 42.42 over pi. If I calculate it, I'll get 27 amps. So I average is equal to 27 amps. Last one, we have to find out the form factor. Fifth one, form factor, which is denoted by Kf. We know that Kf is given by IRMS over I average. Therefore IRMS is 30 amps over I average is 27 amps, which gives you 1.11. So form factor doesn't have a unit because numerator and the denominator, both of them are current values. So there is no unit for form factor. Okay, so I'll summarize everything. First, the problem was they had given you an equation and they have asked you to find out the maximum value, frequency, RMS value, average value, and the form factor. So first we have to write down the given equation. To find out the maximum value, I should write down the standard form of the equation. So after writing the standard form of the equation, if I compare the standard form with the given equation, I can easily write what is the maximum value. So for this example, the maximum value is 42.42 amps. Next, to find out frequency, I need to make use of omega value. So again, by comparing the standard equation with the given equation, if I compare both the equations A and B, omega is given by 628, or omega is equal to 628 radians per second. Therefore, frequency is equal to omega by 2 pi, because omega is equal to 2 pi f, as I have shown here. Therefore, f is equal to omega by 2 pi, which gives 628 by 2 pi, which is equal to 100 hertz. Next, to find the RMS value, I need to make use of the thing is, they have asked you to find out the form factor. So you cannot use peak factor or form factor equation while calculating the RMS value as well as the average value. Okay, you need to make use of the relationship between RMS value and maximum value equation. So we know that IRMS is equal to Im by root 2. So Im we have calculated comparing the equations. So Im is equal to 42.42 over root, or else you can directly write it as 0.707 into Im. Okay, you can directly get the answer. So the IRMS value is 30 amps. Next, to calculate the average value, again I have to go with the relationship between Im and I average. So I average is equal to 2 by pi into Im. So if I do the calculation, I'll get 27 amps. Similarly, to find out the form factor, so we know that form factor is the ratio of RMS value to the average value. So using that formula, I can substitute the values and get the form factor. See, because we are dealing with a sinusoidal quantity, the form factor will always be 1.11. If it is a square quantity, then it would have been different. Next, we look into one more problem. So we have the second problem for which we have to find the solution. The problem is a sinusoidally alternating current of frequency 60 Hz has a maximum value of 15 amps. First thing, you need to write down the equation for instantaneous value. Second, you need to find the value of current after 1 by 200 seconds. Third one, you need to find the time taken for the current to reach 10 amperes for the first time. And finally, you have to find out the average value. Let us find out the solution for this problem. So first we need to write down the given data. So the given data, frequency is given, which is 60 Hertz. Then we have the maximum current Im, which is 15 amps. Now first one, I need to write down the equation of instantaneous value. Instantaneous. So we know that any alternating current is given by the instantaneous equation. I is equal to Im sine omega t. So from the given data I can get to know what is the maximum value, but I need to calculate the omega value, right? So we know that omega is equal to 2 pi f, right? So 2 into pi into the frequency what we have 60, so I'll get 120 pi. Therefore, I can write the instantaneous equation as I is equal to 15 sine 120 pi into t. Amps. Okay. Second one, find the value of current after 1 by 200 second. So second one, I need to find out the current I at t is equal to 1 by 200 seconds. Okay, so what I have to do is I have to substitute this t in the above equation. Therefore, I is equal to 15 sine 120 pi into 1 by 200. See, whenever you are doing this calculation, whenever you are finding out the instantaneous value of the current or voltage at any given time, okay, if you are using pi inside the sinusoidal function, then you have to keep your calculators in radian mode. Okay, this is very important. You need to keep the calculator in radian mode. So you'll get n number of YouTube videos which you can refer on how to set the calculator to radian mode. So if I do this, I'll get 14.27 amps. So the instantaneous value of the current is 14.27 amps at t is equal to 1 by 200 second. Next, I need to find out the time taken for the current to reach 10 amps for the first time. See, in the second section, they have asked you to calculate the instantaneous value at some time 1 by 200 seconds. Wherein in the third part, they are giving the instantaneous current when I is equal to 10 amps. T is equal to what? What will be the time period for the current to reach 10 amps? Because see, the maximum current value is 15 amps, right? So there should be a time between 0 to 15 amps, right? So we are finding that time period. So to do that again, I know I is equal to 15 sine 120 pi t. So they have given the I value, instantaneous value 10 is equal to 15 sine 120 pi t. So I am sending this 15 to the other side. So I will be getting 10 by 15 is equal to sine 120 pi t. So again, I will be sending the sine function from one side to other side. I will get 120 pi t is equal to sine inverse of 10 by 15. So sine inverse of 10 by 15, sine inverse of 0.66. Therefore, I need to find out t. So I'll keep t on one side and I'll say shift everything else to the other side. So sine inverse of 0.66 over 120 pi is equal to 0.0 0.019 seconds. So it requires 0.0019 seconds for the current to reach 10 amperes. Last one, we need to find out average value. So because we have the maximum value, I can use it directly. So I average is equal to 2 by pi into Im is equal to 2 by pi into 15, which gives you 9.55 amps. So I average is equal to 9.55 amps. So this is the complete solution. Let me summarize it. So first, in the problem they have mentioned the frequency and the maximum value, and they have asked you to find out or write down the equation for instantaneous value, find the value of current after 1 by 200 second, and find the time taken for the current to reach 10 amperes, and finally they have asked you to find out the average value. So you'll write the given data first, and then you will start with writing the equation for instantaneous value of the alternating current. So you know that the standard form of any alternating instantaneous value of any alternating quantity is given by Im sin omega t. So Im is directly given in the problem, wherein you have to calculate omega to use it in the sine function. So I have calculated omega is equal, using the formula omega is equal to 2 pi f. So I have substituted f frequency 60 hertz, and I've got the equation as I is equal to 15 sine 120 pi t. Second one, we need to calculate the current value when t is equal to 1 by 200. It is simple, just substitute t in the previous equation what you have got. So the same thing I have done, and the current is 14.27 amperes by the time t is equal to 1 by 200 seconds. See, while doing this calculation, especially the current value at a particular time, you need to keep the calculator in radian mode. Okay, so we have got 14.27 amps at a time t is equal to 1 by 200 seconds. Third one, they have asked you to calculate the time required for the current to reach from 0 to 10 amperes for the very first time. Okay, so you know the instantaneous value, you need to calculate t. So again I have used the instantaneous value equation, and I have done all the simplifications, and finally we get 0.0019 seconds. That means the waveform requires, or the current requires 0.0019 seconds to reach from 0 to 10 amps. Finally, we are supposed to calculate the average value. So I know the relationship between I average and Im, which is given by I average is equal to 2 by pi Im. I have substituted the values, and I have got the average current as 9.55 amps. So this is all about solving problems on instantaneous equation. See, I have done the problems for current parameters. The same thing can be applied for voltage parameters without any change. Only thing is, whenever you are doing calculations for current, you need to use I, alphabet I, wherein whenever you use for voltage, you have to use V or E. Okay, it depends on the author. So, thank you everyone, and I request everyone to subscribe to the channel, and also refer this channel to your friends, and this will be helpful for them to understand basic electrical engineering subject.